The observer-dependent theory of everything proposes that reality is an active construction, built entirely by the observers perceiving it. Early versions of this mathematical framework looked strictly at asymptotic limits. They measured systems that had already reached complete stability, bypassing the chaotic process of actually getting there. This static perspective traces back to the 18th century. Gottfried Wilhelm Leibniz proposed that the universe was made of isolated entities called monads, structures he explicitly described as having no windows. They could not interact with the outside world. Real systems operate differently. Biological cells, human relationships, and planetary ecosystems require constant exchange with their environments to survive. In 1893, Russian mathematician Nikolai Bugaev corrected this historical oversight. He introduced the open monad, arguing that these centers of action possess channels to receive and give information. Tracking a lived reality requires measuring that exact exchange. We have to map a system's evolutionary trajectory as it trades energy and information with the universe over time. Mathematically, an open observer operates on two specific channels. It pulls in external coherence through learning and participating in collective acts, and it bleeds out coherence through internal doubt and entropy. Bugaev's formulation of this continuous exchange system was decades ahead of mainstream science. It would be another 36 years before Alfred North Whitehead introduced similar concepts in his process philosophy in 1929. And it wasn't until 1948 that Norbert Wiener formalized these interactive, feedback-driven loops into the field of cybernetics. Applying this open system math to human behavior gives us a rigorous definition of a very abstract concept: love. In this framework, a stable relationship requires simultaneous mutual growth. Two nodes synchronize their inflow and outflow channels to drive each other's coherence upward. Stability in a dynamic universe is never achieved by locking a system down. It is the result of continuous coevolution. When this mechanic scales up from a single pair to a much larger group, it creates a collective attractor. The math underlying this theory includes a conditional reachability theorem. It shows an isolated observer rarely generates enough internal coherence to stabilize their own trajectory, causing natural drift. A collective attractor supplies necessary inflow. Pulling the coherence of multiple participants generates enough gravity to pull erratic individuals toward a shared, highly stable fixed point. We see these mathematical structures in everyday life: a tight-knit family of four, a scientific community sharing a framework, or a deeply aligned creative team, all function as attractors for their members. The prominent groups of any historical period are simply the attractors that reached a critical threshold of coherence, generating enough gravity to anchor the reality of the individuals caught in their orbit. This energy information density metric calculates an observer's ontological footprint by subtracting internal contradiction from their total coherence. Consider two lives of equal length. The first maintains high coherence, leaving a deeply rooted historical imprint. The second experiences high doubt, and their trajectory mathematically evaporates. The math makes a strict distinction. The duration of a system's existence is completely separate from the actual density of its life. Applying this density metric to the entire cosmos reveals a strict two-tiered stratification of reality. The first tier is the ontological level. At this scale, anything with a positive level of coherence, a single biological cell, a human being, or a galaxy, technically qualifies as an observer. They exist. The second tier is the actual historical level. This measures an observer's effective agency at a specific moment in time, calculated by multiplying their current coherence by the strength of the collective attractor they belong to. While countless entities populate the ontological background, the actual history of the universe is written exclusively by the specific groups generating highly dense, interconnected world lines. The universe isn't an empty container we passively move through. Our shared reality is a physical, measurable record of our collective coevolution.